We're ready to get started here. Welcome everybody to the MySQL High Availability session. My name is Alex Rodling. I'm with the MySQL team. And I'd like to introduce Chris Schneider from Ning. And Chris has been using MySQL for the better part of a decade. He's done architecture and design and development for various companies, including Facebook, VMware, Plaxo, etc. So over to you.
Thank you very much. So, MySQL High Availability Solutions, keeping it simple, kinda, and I do emphasize kinda because in MySQL, it's very easy to go to the highest level of availability, which I believe was just shown, like MySQL cluster, 5 nines of availability. So today we have to really kind of focus on what is high availability, how do we get there, what are the levels of availability, and so some of the topics we're going to talk about today. High availability terms and concepts, levels of availability, which is very important because a lot of companies actually go for certain levels, probably not 5 nines from the get-go, especially when you're talking about Web 2.0 companies. What technologies are there for MySQL high availability? Some examples of how different levels of availability are implemented, and how we leverage high availability. So it's a lot to go over in 40 minutes, so I'm going to be moving pretty fast. So an HA overview, high availability is the availability of a system or service despite hardware failures. So when you think of HA, you really have to think of the 5 nines of availability. 5 nines is kind of the creme de la creme. We want to do 100%, but I haven't worked on a system yet that hasn't gone down at least once. A lot of companies are okay with 3 nines, especially in Web 2.0. They want something up and running, something there for their system, for their customers to actually have available and not always down. 2 ways to gain high availability is both redundant hardware and software, and then commercial software. Some more HA terms is continuous availability, kind of like what I just said. Despite hardware failures, there's no disruption in actual service to your customers during a failover, during a rebuild, and so on and so forth. A single point of failure, do you have anything out there in your environment that actually would cause your entire system to go down, or hundreds of man hours to go into rebuilding something? And we'll kind of get into a situation, maybe not hundreds of hours, but a situation like that in the near future. Failover and failover situations. Failover is actually when a piece of hardware fails and you have to go to a different, better piece of hardware that actually is working. And then service level agreements. Some service level agreements are at 5 seconds for your customers, or they can be 15 minutes of outage is definitely okay. You also have to bring into consideration data integrity when you talk about your service level agreements. Scaling up. Yeah, I love clip art. Vertically scaling up your hardware, bigger, better, stronger, faster. I'm not sure if everybody in this room knows what an E25K is. Very, very expensive piece of Sun hardware for like $5 million, and so. But you can fit an awful lot of information on an E25K, but it definitely costs a lot of money. Web 2.0 companies typically don't have $5 million to spend on one enormous server, so they're going to go with more commodity hardware. Maintaining vertical scale is relatively difficult as well. You need somebody that really knows what they're doing with that piece of hardware in particular to actually keep running it. 2 examples of companies on the MySQL front that are examples of vertical scaling would be Schooner, who has a kind of a black box server for both Memcache and MySQL. It is a little bit pricey, but at the same time, the consolidation ratios that you can get with their hardware are pretty extreme. Same thing with Fusion.io. Fusion.io is actually another company that does flash storage, and basically is giving you higher throughput for, a somewhat nominal fee, but it is more expensive than your traditional spinning disk or SSD. Scaling out is another big term inside of high availability, especially in Web 2.0 companies. Everybody really wants to scale out, so adding more commodity hardware is usually a lot easier than adding one really, really big server every year. Commodity hardware like Dell, HP, Sun, which is now Oracle, 1 to 2 or 1, 2, or 4 U boxes is usually the class of servers that you're talking about. So Dell 2850, Dell 1950, Sun 4140, Sun 4170, stuff like that. You're adding servers or sharding out, if you will, to increase capacity or performance. So on this side, it kind of makes sense. Hey, it's free, it's open source hardware, why not just scale out? Well, by free I mean the actual software that you're running on the commodity hardware is free, so really your only cost is your employees and the actual hardware itself, which is normally nominal considering. Synchronous versus asynchronous replication is definitely something that high availability has inside of it. So with higher availability and high availability, you're really looking at synchronous replication where one write comes in and it's actually committed to two locations. So you have an identical data set and you don't have to wait like you do in asynchronous replication where a write would go through on a master server and then it would have to happen on the master server, however long that takes, and then it would have to happen on the slave server. So that kind of gives you a diagram, asynchronous versus synchronous. A lot of people probably already know that. So getting into lower levels of availability, we have to know what the lower levels of availability are before we get into the really, really high levels of availability. So available, I call, is just a single node. Yeah, you have something up there. It might be a backup server. It might be serving some piece of content for some customer out there. But there's really nothing more to it than a vanilla MySQL instance. Availability is like an unmanaged replication set, where you just have a master slave. Even more availability would be a managed replication with possible third-party software that would handle your backups, your point-in-time recoveries, maybe even failover with keepalived or heartbeat. Higher levels of availability, and I do say higher because there's one in there that's not exactly the highest level. So even more availability is actually my favorite, right now at least, which is managed multi-master, which basically has bidirectional replication and either a passive or a hot failover. Replication with custom third-party software to run your failovers, to run your backups, to run your point-in-time recoveries. The highest availability that I've seen to date both comes in DRBD and MySQL cluster. So this is kind of a graph scale on the 5 nines of availability based on what technology that you're actually using. So replication, you can get about 3 nines, 4 nines, sometimes less, sometimes more, depending on how you're actually measuring your uptime. DRBD, you can pretty much get 4 nines to 5 nines, and then MySQL cluster, if you set it up correctly and you're using it right, you can actually get very, 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 very high throughput and high availability up to 5 nines. So everybody always wants to say, well, what does the nines actually equate to in downtime? So downtime per year, 1 9 means that your system can be down for 35 days, which is absolutely horrible. Oh, shirt caught on fire. 2 nines is 4 days a year your systems can actually be unavailable. 3 nines, 8 hours. 4 nines, 50 minutes, and then 5 nines is 5 minutes a year your system can actually be down or unavailable. 5 minutes a year is actually, if you can get there, it's really awesome, but it's can be very difficult. Measurements, again, how are you actually going to measure it? Are you going to measure it by cluster? Are you going to measure it by node? Are you going to measure it by system, data center, the actual system that those servers are attached to? So it all depends. I kind of like to measure it by customer. So I have a certain number of customers on one cluster. Like I have 100,000 users on one cluster. And all of a sudden I get, a minute of downtime. So I'm not going to actually apply that. Well, I hope I can. Not apply that 1 minute of downtime to the entire system. I just want to apply it to that 100,000 users. So the other 100,000 users and the other 100,000 users, they were fully up. So however you want to measure it, I like to measure it on a per user basis just because it lowers my the time that I'm actually down system-wide. Unmanaged replication, I've kind of alluded to, it's just a master slave. Your slave's really not doing anything. It's not really taking reads, but it could. It's not really taking backups, but it could. It's definitely asynchronous replication, so you're using MySQL's built-in replication mechanism. This is a lot of Web 2.0 companies actually start here. So you're going to have one master server taking reads and writes, and you're going to have one slave server that just kind of sits there for, oh no, what happens when my master goes down. There's no automated break fix, not really any monitoring either. Possibly you could have some monitoring in place. So managed replication has just a little bit more as far as system usability and functionality for a DBA or anybody else. It's production ready, but not the best. It has less risk than unmanaged. It's higher end redundant hardware. It's also using asynchronous one-way replication. There's one master server that's taking reads and writes, one slave server that's possibly doing reads. Doesn't have to, but it's definitely available to do so. It's taking backups, and then it's taking ETL processes, internal processes. Doing data aggregation or what have you, and pushing that off to either Hadoop or Netezza or wherever you're going to push it off to. It does have automatic break fix. Like, let's say my replica actually breaks down. I don't want to always, log in at 2 o'clock in the morning if something happens. I just want to make sure it's going to fix itself, and I wrote a script to do that, and now it just fixes itself. And it has to be fully monitored if it is managed, so you have to know everything that's really happening. And MySQL Enterprise Monitor is awesome by doing that. So replication failovers, unmanaged replication. Again, you have excessive customer downtime, which is really what we're trying to avoid, especially when we're talking about high availability. It's a manual process that involves multiple teams. Rebuilding the old master server, after a failover can be time-consuming, and you can even take more downtime at that time. It's hard to keep everything straight at 3 o'clock in the morning when you're trying to do all this and trying to coordinate multiple teams as well, so unmanaged is really not the best place to go. Managed replication is still excessive customer downtime. However, rebuilding the old master after the slave actually failed can be a little bit easier, and you might not have to take any customer downtime to rebuild another server. It's also hard to keep straight at 3 o'clock in the morning. Managed replication. So, I think I went back. So multi-master hot standby is my absolute favorite. It's bidirectional replication. One master server reads and writes. You have possible backups. I use the community version of NODB Hot Backup, which is now Enterprise Backup, which is called Extra Backup. And MK Query Digest is something I also use, and that actually does keep the passive slave to a hot standby. One hot standby server, it is taking on read activity. Backups are usually MySQL dump. I'm usually using NODB in situations like this, so I can use single transaction MySQL dumps. And all your ETL processes are also off on your passive server. It is asynchronous bidirectional two-way replication. So the master server is replicating to the hot standby, and the hot standby is actually replicating to the master server. However, it's only one write location at a time, so you're only actually writing information to your master server. It has automatic break fix, semi-automated or fully automated IP failover. In the examples I'm going to show you with keepalived, it's very easy to use. So this is my wonderful diagram of my multi-master hot standby server. You have the cloud up top, reads or writes going into switch 1 and side 1, rack 1, UPS 1. The server, let's just say in this case, has redundant NICs, redundant disks that are RAID 10, so you can lose up to half of your disks and still move on, and redundant power supplies. With redundant hot swappable hardware, you're a lot less likely to actually experience downtime, because having 2 power supplies go out or 2 switches go out is highly improbable in a situation like this, especially when you have failovers that have redundant everything. And then MK Query Digest as well definitely helps the hot standby. Actually, has anybody used the Mott kit, MK Query Digest? Anybody out there? Anyway, it's something that is really awesome. It has a great scripts inside of it for everything, and MK Query Digest is one of the most useful for keeping the caches hot on your hot standby or replicated server. So the most important things, again, just to reiterate, redundant hardware all the way. Bidirectional replication. keepalived, which is basically your VIP and IP management failovers. MK query digest, so you actually are keeping that hot standby server hot. You want to keep that hot so when you do failover, you're not priming your caches for 45 minutes to an hour to actually get everything up and running so your customers are at full capacity and their queries are returning very quickly. Extra backup is also something that's very necessary inside of an HA environment. You want to actually be able to take point-in-time recovery. You want to take MySQL backups, in this case specifically with NODB, that don't disrupt the user. And extra backup is definitely a way that we can do that. So again, keeping caching hot, MK query digest, we've already gone into that. Two other tools in the mod kit. MK table checksums. Something with asynchronous replication is you never really know if your data is correct. You're just kind of taking it at the replication's word. So using a tool that can do a checksum from the master server to the passive failover server is actually quite reassuring, and you can automate this process. You can do a subset of tables every day and kind of work through your environment. And as you come up to possible inconsistencies, then you can focus there instead of just saying, oh, well, I guess everything's okay. And then MK table sync is also another tool that you can use. If you ever do find an inconsistency, you can actually use these automated tools from the mod kit to rebuild whatever data is lost, or you can always just take a full snapshot with extra backup and rebuild your cluster. Either way. Keepalived and VIP management or floating IPs, very, very important inside of this setup. It's not the only solution. There are other proxied solutions that you can use, but for this example, for what I like, for what I'm comfortable with, keepalived works very well, and it's extremely simple to implement. The uses for keepalived is basically for hardware failures. If something really does go wrong, like you lose an entire rack in UPS, or somebody breaks into your data center and lights your server on fire or something like that, you really want something there to say, uh-oh, I really just want to fail over that IP that the application is actually pointing its reads and writes to over to the new server that's completely safe, that's on a new rack, that's backed up and on a new switch. It's really good for kernel panics, just in case a kernel panic happens, you run into some bug that came up for some reason. I've had it happen before, but custom monitoring scripts to detect NODB corruption or other MySQL problems is something else that you can actually program into keepalived. So if you run your checks inside of MySQL or some script that runs a bunch of checks inside of MySQL, you can actually determine whether NODB corrupted or something went wrong inside of MySQL. You're not able to ping it anymore, so it wasn't a hardware failure. It was actually a failure on MySQL's part. So you can actually trigger a failover based on a failure of MySQL without having a hardware failure, and you can put that right into keepalived. So what we want, keepalived, the VIP management continued, is we want single one-way failover, and this is very important because you can actually set up keepalived to do the floating IP that would fail over, and maybe it was a false positive, it failed over, and then it's like, oh, okay, that server's available again, so the IP flips back, and then it keeps on flipping. So that's something that we really want to avoid inside of keepalived. To do that, you have to make sure that you set up the priorities of the servers correctly. The priority of the master server is actually set to backup inside the keepalived configuration file with a priority of 100. And the slave server or the hot backup server would actually be set up the exact same way, backup and 100 priority. The reason why we do that is when we start keepalived initially on a master server who's going to be taking writes, it will claim that IP address, leave it on the master server, and then we start it on the slave, and it says, okay, well that IP is already taken, and I don't really need to do anything with it until something happens. So the master goes down, the IP fails over, but if the master ever comes back up, it's still a backup because that IP is being used and it's not actually set as a master server where the IP would just keep flapping back and forth, which is a dangerous situation to be in. So After going through all this, in the MySQL world, you have to build a lot. You have to think kind of outside the box and think with your experience and your skill set on what's really going to work with higher levels of availability. Everything that I've just went over as far as redundant hardware and multi-master hot backups and multi-master failover, there's actually a really cool set of scripts out there, acronym MMM for a multi-master replication manager for MySQL. Everything that I just said, basically, from monitoring to IP management to keeping your caches hot to everything, is actually already in the MMM toolkit that you can actually go download and you can even contribute to if you like. So there's no need to have, keepalived, no need to have any other third-party moving parts. It's kind of a one-stop shop for everybody. It will perform monitoring, failovers, management of MySQL master replication. It's agent-based monitoring, so there is some overhead as far as agents are concerned, but it's going to be nominal as far as the usage on the system. It requires at least 2 MySQL servers, and it can also read balance standard master-slave configuration. So if you have a master server and then like 23, 24, 100 slaves, however many you have, it can actually do read balancing for you, so you don't have to have a piece of hardware like an ACE or another load balancer and they're doing your load balancing for you. So all of this wonderful talk about failovers and trying to actually leverage that in a different way other than a hardware failover or NODB corruption or MySQL is not available anymore. Some real-world examples I've ran into was a table schema change on a very, very, very large table. I consider very, very large tables in MySQL to be, it can be 100 gig, 130 gig, 150 gig. Well, if you've ever tried to run an alter table on a 150 gig table, I bet you it never finished. For example, I ran one and let it run in a test environment for 2 weeks, and after 2 weeks I just kind of said, done, I have to find a new way to do this. So the problem with the above situation is that do you have enough disk space? Because MySQL is going to have to make a copy of that table. So if the table is 150 gig, it's going to have to copy 150 gig and then run the schema change there, and then all of a sudden it's done, and I'm going to replace the new table with the old table. If it's NODB, the table space fragmentation and growth is going to be immense. And how much customer downtime do we really have? So a 120 gig table, after 2 weeks, you really can't have 2 weeks of downtime. So a schema change on a large scale table, or schema change on large tables is actually quite simple to do in an automated failover, redundant, highly available multi-master situation. This is a very, very loose process because there's so many different ways to do this and so many situations where you would do something else or something more. But basically you would stop replication. You would run an activity on the hot standby or the passive master or the slave server. That either being the alter table, like on a 5 gigabyte table, or a full dump out and reload of that table with a different schema. With that kind of situation, it's select an out file, load data in file, dumping by primary key order just for speed in the end. You would fail to VIP over to the new schema, and then you would either start slave, so it replicates down and takes all that downtime, or not downtime, but it takes that much time on the actual slave server to replicate through, or you would do the exact same dump out and reload on the old master server while you're serving your customers up with the new schema. So it all depends. In any situation, you can go either way. You can do a full dump out and reload of your entire data set if you have the room or if you have the time. Lots of different ways, but that should get your brains thinking on why would I ever use multi-master hot standby. Process benefits, way less downtime. Sure, it's more operational cost and more operational time for me, or at least it can be. But at the same time, I want to make my customers happy. I want to make them available. I want to make sure that my product is always available for them. So this is really the key fact, and everything that I like to do with high availability is I want my customers to be satisfied. If you choose the dump out and reload method, with select an out file and load data in file, you have the added benefit of defragmentation. Whether that be MyISAM or InnoDB, you'll still get defragmented table spaces or defragmented MYI and MYD, so MySQL indexes and MySQL data. You can actually regain, if your table spaces are already way overblown, you'll actually regain disk space based on a full dump out and reload as well. And this is something that you can do very easily inside of a multi-master setup. So the number one challenge with MySQL replication, I guess, is that it's single-threaded. It's a huge bottleneck. It can break in a lot of ways, whether it be a duplicate key if you have referential integrity inside of your database with cascading deletes, and somebody thought that they would delete a key on the slave, and now something happens on the master and it replicates through and says, oh, that key is not there, so I'm going to break replication. Max allowed packet, that's always a very, very popular way to break replication. And then replication can also fall behind because writes are coming in multi-threaded on the master and it's serialized on the slave. It can also be unreliable. So DRBD, we're getting into the 4 to 5 nines of availability now. DRBD is absolutely awesome. Great technology. It's been around forever. The components needed for success is MySQL, Heartbeat, DRBD, and those are the three things that really you're going to run a highly available system with. It's synchronous replication. It's distributed storage. There's no special network components needed like an HBA, but you will use a crossover cable. Has great performance on block versus statement level replication. Manages inconsistencies. Streamlines many recovery actions, so it's not a manual process anymore. And then it has automated IP management. So here's our DRBD diagram. Kind of notice the active server, and I do mean active because all of your everything, reads and writes, actually have to be on your active server. The passive server really isn't there for anything else other than failover in case of a hardware problem. So I like to think of the active server and the passive server as one server in and of itself because they're identical copies and you can't really do anything else with your passive server. Heartbeat needs multiple paths, that's why you see the heart on both the crossover link and the LAN link to avoid a split brain scenario. And then please note also that the two-port gigabyte Ethernet cards just for redundancy and eliminating a single point of failure on the network side. So what happens during a DRBD failover is all of a sudden, the active server goes down for one reason or another, catches on fire, and Heartbeat would say, oh, I can't connect to the server anymore, so I'm just going to fail all of that, the floating IP or VIP over to the former passive server over to the active server. Resyncing data after a failure is done automatically, which is awesome. So now I don't have to do an InnoDB hot backup or extra backup. I can actually just have DRBD resync the data for me on those nodes, as long as the node is okay again. There's no interruptions of service during resyncing of data, leading to higher availability, higher nines. Scaling out with DRBD is a little difficult. Sometimes you don't have all the writes in the world, but you really have a lot of reads, and one server might not be able to take that on. So DRBD replicates the entire block device. This includes data needed for replication, which is like the binary logs. Slaves can attach the virtual IP address managed by Heartbeat and the cluster situation. And then we can actually replicate from that actual virtual IP. You just have to make sure you're going to the virtual IP, not the management IP of the box. And this is kind of what scale out with DRBD looks like. So I'm actually looking at 3 slave servers that are just replicating off of the VIP. And now those slave servers are available for reads or backups or snapshots or ETL processes, while I have the exact same highly available write activity inside of the DRBD cluster. Now let's say something goes wrong with the active server and the VIP fails over. Well, due to the asynchronous nature of replication, I still have all of my binary logs, everything. The only thing that really changed was the IP failed over from the active to the passive server, which is now the passive, or now the active server, and replication just continues and continues and continues. It's actually a really cool thing to do. So the highest level of availability I've seen really is MySQL cluster. Cluster is a great, awesome, very, very available technology that came out not too long ago. Actually, it's been around for a long time, but it's really become popular in the last few years. Very popular in telco. Redundant nodes. It eliminates single points of failure with redundant hardware. Multiple networking connections, whether it's SAN or RAID. Share nothing storage. Automatic data failover is built in. Synchronous replication is transactional. Online backups, easy node addition, so if a node does go down and you need to add a new one in, it's actually very, very easy to do that. There's no VIP failover required. This is more hardware based. Automatic resynchronization of data, so this also takes care of actually snapshotting your data over to another node and replicating and then bringing that node back into the actual cluster for usage of the entire cluster. It's scale up and scale out made easy. MySQL cluster cons, however, and the first one on there is geographical redundancy. The reason why it's a con is because it is done through MySQL replication, which is single-threaded asynchronous. However, if you do need geographical redundancy, then all you're really dealing with is the same old problems inside of replication, which is not really too difficult to deal with. This isn't in-memory data storage, or at least indexed columns. It does not work well for really, really large data sets. It doesn't really work well for very complex, very normalized data sets either, where you have a whole bunch of joins. So the MySQL cluster diagram, up at the top you have your API interfaces, which is your NDB API servers that you can actually access directly to the NDB storage engines. Or you have MySQL that you can actually reference the data as well. The really great thing about cluster as well is the management server, which acts as an arbitrator. So everything goes through arbitration. And this actually is very good to have, because if we didn't have the arbitrator, we could very easily have a split brain situation, and then the entire node and basically this entire thing would just kind of go downhill, and you don't know if your data is really correct or not. But as everything goes through the arbitrator, you have the two-phase commit, which makes copies of your data on either node group 1 or node group 2. And so you can lose one whole server from node group 1 and one whole server from node group 2, and you can still be up and running, bring new servers in, and you're good to go. So when to use MySQL cluster, HA is a must. Very large amount of update and selects. Mostly searching on clustered indexes. Fast failover and crash recovery is needed, and again, geographical redundancy is really something you can do, so if you really need that, cluster is probably still good for you. When not to use it, large data sets. As a replacement for my ISAM or InnoDB, as a replacement for Memcache, don't ever replace cluster with Memcache. Memcache is a lot better at what it does. Complex schemas or joins, you really don't want to use cluster. When you have large data sets as well. Something that's not going to fit in your memory. Thanks for listening, guys. If there are any questions, I'll be around. Any questions right now? If I don't see you, the lights are too bright. No questions? Wow. You guys are all experts now in HA. Yes, sir. What? Uh-huh. So the question was, how do we actually manage failovers inside of a cluster? Cluster is node-based. So, do we have time? Like 2 minutes. So, let's say in node group 1, one of the servers actually falls out for one reason or another. The arbitrator, management server, would actually realize that there's something wrong with that server, pull it out, and then whatever alerting goes on, everything would keep running as far as reads and writes are concerned. But that server would actually fall out and stay out until somebody either fixed it or a DBA would go look at the box or have to bring the box back up or add a new node because the whole node went completely down. After you actually bring that server back to a good state, just issue like a one-liner command to the arbitrator that says, oh, hey, this server's okay, up and running, and it would actually be brought back in into the actual node group. So yeah, I was actually going to go into that in a little bit more detail, but it was only a 40-minute presentation. Any other questions? Thank you, guys.